Hey there, how y'all doing? We're going to look at 5.2 on composition of functions today. And so a couple of objectives that we're going to look at. The first is being able to perform the composition of functions and to be able to apply the composition of functions to problems. And so FBF 1 says that writing a function that describes a relationship between two quantities, and that's exactly what we're going to do with compositions of functions. And so let's talk about what a composition of a function is. Here's the definition, and we'll get into the nitty-gritty of how it actually works. So the definition is this. It says, suppose that f and g are functions that the range of g, remember ranges are outputs, right? The range of g is a subset, and we'll talk about that word in a second, of the domain, so that's our inputs of the f. Then the composition f of g, and so this little notation here is read f of g, can be described by the following. That f of g of x means that f being inputted, so you have the f function, and then you have g of x inside of that. Now, what does that mean? Let's draw three little bubbles here. Let's talk about how these functions are going to work, and we're going to work from bubble 1 to bubble 2, and bubble 2 to bubble 3. Now, if you were in my foundations class a few weeks ago, we talked about mapping diagrams, and so kind of reviewing this from Algebra 1, remember that if I just have the two bubbles, right, we could relate our x's to our y's, right? And this would go to this, and this would go to this, right? But we're going to be comparing two functions. And so my first function will be the domain of the inside function, which is the g function. And of course, my domain relates to my range of the g function. But let's go back to that definition. It says that suppose that f and g are functions such that the range of g is a subset of the domain of f, which means if this is the range of g, it's also going to restrict any possible domain of my f function. And then, of course, I have the domains of f, which would give me the range of the f function. Now, again, in theory here, this problem is a little bit complicated to understand in terms of how it works out. And so we're going to look at some problems to get a better grip on that. So let's take a look at example 1. Let's say we're given the following two functions. F of x is negative x plus 8, and g of x is 2x squared plus x. And we're asked to find f of g of x. Now, I will tell you with compositions of functions, the easiest thing to do here is rewrite this so you see which function is outside and which function is inside, because that will help you understand which function is going to go inside the other. Because think about with functions, right? If I do f of 8, right, what would I do with that 8? I would plug it in to the x in the f function. But here, I'm going to take the entire g of x function and plug it into the f function. And so what's going to happen is I'm going to take all of this, and everywhere I see x, I'm going to substitute it in. So again, I'm going to take all of the g function and substitute it in just where I see the x. And so what we're going to get is this. We're going to get the negative, and then I see the x. I'm going to replace it with the entire g of x function, 2x squared plus x. And then I've got the plus 8 out back. So again, here's the g of x function that I've substituted in to the f of x function. Now, I can simplify this, right? I can distribute this negative in, and I get negative 2x squared minus x plus 8. And if there were any like terms to combine, I would do that. But in the end here, f of g, and now it's very important that is an open circle there, f of g of x, and I left myself no space, f of g of x. And it's hard for me to do a very small o like it is here, but let's talk about that circle there for a minute. If I put a dot like we did in section 1, we're talking about multiplication. If I've got this circle operator, then we're doing compositions. So make sure you understand that notation. Again, a regular dot would be multiplication, but an open circle like this is compositions. Okay? So Let's talk about problem B, f of g of 2. Now, I just did f of g of x, right? And so I can take this information, and now what I want to plug in? I want to plug in 2 for the x. Now, I'm going to show you there's two ways to do this problem. Method number 1 is to plug in for the x after we've done the composition of the two functions. And so I'm going to get, everywhere I see the x, I'm going to plug in 2 minus the 2 plus the 8, and then we'll do order of operations to simplify this. And so negative 2 times the 4 minus the 2 plus the 8. This will give us negative 8 minus 2 plus 8. Negative 8 and positive 8 will cancel, and so I'm just left that f of g of 2 is equal to negative 2. Now, I told you there's two methods to solving this problem. Now, because I had already done the work of doing the composition, that's the primary method I'm going to use. But let's say I didn't have that composition already done. Let's say I'm starting just with the given information at the top. I wasn't told to do this step. The other way to do this is to think about what we talked about here with the three bubbles. So I'm going to plug in that 2 into the g function, get what it results for the g function, plug that value into the f function, and get its result to give me the final answer of the composition for that individual value. And so we're going to go through those steps. So again, we're going to start with the interior function. So when I write this out, it's going to be f of g of 2, which means I've got f of g of 2, which I'm first going to plug into the g function. And so doing that, I'm plugging in 2 into that yellow highlight there. 2 times the 2 squared plus, and again, I'm plugging in for the x here, 2. And so when we get that, now again, you've noticed I've erased the f here, because right now I'm only dealing with the g function. So I'm going to get 2 times 4 plus the 2, and so that's 8 plus 2, which is 10. So g of 2 is equal to 10. Now, I'm going to take my result and plug that into the f function. So I'm going to take f of 10 and plug it into the f function. It's negative x plus 8. And so negative of 10 plus the 8. And so f of 10 is equal to negative 10 plus 8, which f of 10 would be equal to negative 2. Meaning that f of g of x is equal to negative 2. And if I zoom this out and we look at both sides, we're going to see here and here, I got the same result. That's the key, because the compositions work either way. We can combine the two functions first and then plug in the value we're looking for from our domain, or I can do the two functions separately, and in the middle, I'm taking the result of the interior function and substituting that into as the domain value of the exterior function, okay? So let's look at problem C here. G of f of x, or sorry, g of f of 2. So do you think it's going to come out to the same result that we got for f of g? Are these going to come out the same? Let's check it out. So again, I'm going to rewrite this as g of f of 2. So I understand which way I'm plugging this in. And so I'm first going to be substituting into the f function this time. So negative x plus 8. And so f of 2 is equal to negative x, that's the negative 2, plus the 8. And so f of 2 is equal to negative 2 plus 8. And you're probably being like, why are you doing separate steps here? I'm making sure that I'm explaining everything really clear, because I want y'all to get this. So f of 2 is equal to 6. So now I'm going to take my g function, and I'm taking this value and putting it here, and I'm going to be plugging into the g function that I was given, and that's 2x squared plus x. So 2x squared plus x. Simplifying this out, we get 2 times 36 plus 6. So 72 plus 6 is equal to 78. So g of 6 is equal to 78, meaning that g of f of 2 is equal to 78. It's a whole different number here. So understand that the order of compositions definitely matters. Now, there are a few exceptions to that rule, and we'll talk about those exceptions as we go along with this. But generally, f of g and g of f are not going to result in the same value. Again, there is a certain case that we'll talk about later on in this chapter when it will work, but today we're not going to talk about that specifically. Okay? So let's talk about other ways we deal with compositions. And so we can look at compositions from a table and to evaluate the inside function first and then use that number to evaluate for the outside function. And so let's say we're given this table here. And you see I've got some x values, and then I've got 3 different defined functions here, an f of x function, a g of x function, and an h of x function. And so again, think about the bubbles, right? I'm going to start with the inside function, right? Inside. Let's redo these bubbles so I can write correctly. So we start with the inside function, which yields the range of that function, range of the inside, which I'm then going to use to go to the domain of the outside function, which will yield the range value of the outside function, and that's also the range of the composition. Okay? So again, these two things are related in the end. So let's look at our first function, f of g of negative 2. Again, I would recommend that you rewrite this so it's not with the circle form, but it's with the interior, exterior of these functions. So again, watch the highlight pattern I'm going to use here. And I'll draw some arrows to show you where I'm going. So I'm starting with the negative 2. And which function's interior? I'm looking at g of x, right? So I'm going to go to 1 for g of x, okay? And so we're going to get that. So that g of negative 2 is equal to 1, right? Then I'm going to take this and plug it in here to now find f of 1. And so doing that, I'm now going to be going, so this is going to come here, right? Because that's now my domain of the exterior function that I'm doing. And which function am I looking at? I'm looking at the f function. And so that's going to give me positive 2. And so f of 1 is equal to 2, which means that f of g of negative 2 is equal to positive 2. Again, start with your x, go to your interior function. That becomes your domain value for the exterior function to give you the range of it. So again, start at the negative 2, went to the 1. I look at the 1 as my new domain and get the 2 as my final range value. Again, follow the pattern, look at the arrows, and think about the order in which these functions are operated. And that's the thing, is order of operations never went away, right? We're still doing the order of operations because we're dealing with parentheses here. And remember, you work parentheses from inside out. You work what's inside the deepest parenthesis and you work your way out until there's no parentheses left. You don't work from outside in. Okay? So let's look at B, h of g of 2. So h of g of 2, I'm going to erase the highlights that I had here. And I want you to pause the video for a second. H of g of 2. And I want you to take a second, pause the video now, and try this one and see what you get. All right, so h of g of 2. Let's look at that. So I'm going to start at the 2. Remember which one's inside? H of g. So the g is the inside. So I'm going into here, so I get 0. And so I'm going to take that 0 up to here, right? And now I'm going to do the h function because that's my exterior function. So 0 going to my h, that gets me to the negative 2. And so writing this out, let's do it in the steps. H of g of 2. So g of 2 was equal to, we said 0. and h of 0 is equal to -2. And so h of g of 2 is equal to -2. So again, these aren't hard problems. You just have to understand the order in which they're done. All right. So there's a couple more here. You can try them on your own, and I'll put the answers here on the bottom of the video. They'll be in the notes that I'll post online, but you can try them on your own if you'd like. All right. All right. So let's look at example 3: compositions from a graph. Use the given graph to find each value. For both examples, we're going to see here A and B. The green line will be the f of x function, and the purple line will be the g of x. So I'm going to label those on the graph now. So this is my f of x, and the purple is my g of x. And so it works the same way that we just did on the table. And so let's pay attention to the function organization here. I'm looking for g of f of 1. So that's g of f of 1. And remember, we work which direction? Inside out. So I'm going to go to the f function first. So what is f of 1? Well, that's where my x is 1. What's the y value? Well, f of 1 is equal to 3 because I can get the order pair 1, 3, right? So now we go to the g function. G of what value? The 3 comes here, right? So I'm not going to look at x being 1. I'm looking at x being 3. So x being 3 gets me here, which gets me the order pair 3, -5. So g of 3 is equal to -5, meaning that g of f of 1 is equal to -5. So again, just like the tables, we got to understand the order in which these go. But once you understand that, these are so easy, y'all. Okay? All right, last problem. F of g of 2. F of g of 2. And again, remember that the green is our f of x function, so I'm going to label that here, f of x. And the purple was our g of x function. G of x, right? Is that what we said above? Yep. F of x is green, g of x is purple. All right, so f of g of 2. F of g of 2. So f of g of 2 means that g of 2, so I'm going to start when x is 2, the g is what? 4. Okay, now we'll go do f of what value? The 4. So f of 4 gives me what value? This is at the order pair 4 what? -3. So f of g, and again, let's try and make sure that is a circle and not a dot. F of g of 2 is equal to -3. And that's it. So again, some of the problems you're going to look at with the application are going to do the same thing, right? You're going to have two functions that are being combined together. Think about which one's your interior, which one's your exterior. That's it for this lesson, y'all. The word of the day is composition. Again, the word of the day is composition. And so I hope y'all have a great day. Again, if you need help, the Zoom class will be open from 1 to 2, or email me if you need help at any other time. Again, have a great day, and I'll catch y'all later.